Good day, folks. This is tutorial number 27, where I'm going to be using the dynamic scenario creation in the 3D experience to solve a classical problem in dynamics. It's the kind of thing that one does in the second year dynamics class based on conservation of energy and conservation of momentum. But what you would like to do is to model it with the solver in 3D experience as a rigid body dynamics problem and see how well it compares with the analytical solution. So we have a block, that orange piece that is sliding down a ramp, and the ramp itself is placed on a stationary ground. So as the ball slides down, the ramp will move to the left. I'm assuming that there's no friction to simplify the problem when it comes to hand calculation. Now, I have some information here as far as the sizes are concerned, which I'm going to be using later on. Everything is in SI units. So notice that the height of the ramp, I take the size of the block into consideration. So the block basically, when it reaches that end, it has descended by the amount h, and the mass of the block is mb. The mass of the ramp is mr. And the first thing that I'm going to do is to indicate what is the relationship between the velocity of the block, velocity of the ramp, and the relative velocity of the block with respect to the ramp. So this is the kind of thing that you basically come from elementary vectors. The ramp moves to the right. Yes, of course, it does move to the left, but we can pretend that it moves to the right. Later on, the value of VR is going to be negative, of course. So assuming that the ramp moves to the right, the block relative to the ramp goes along a 30-degree angle, and this is going to be the velocity of the block, which is not parallel to the ramp, to the surface of the ramp. What is parallel to the surface of the ramp is actually velocity of the block relative to the ramp. So what we do is to write down the conservation of energy. In other words, initially there is no motion. Initially kinetic energy is zero, but there is a potential energy, which is just that mb, the mass of the block, times g. That's going to be the weight and height, mgh. It's right there. And this is going to be converted into kinetic energy, which is written on the right hand side. We also have there is no external force in the horizontal direction. Therefore, there is conservation of momentum in the horizontal direction. That's written here at the third line. And this is just the law of the cosine. Remember, there are essentially three unknowns here: velocity of the block, velocity of the ramp, and velocity of the block relative to the ramp. So basically, you solve these three equations for VB, VR, and relative velocity, and second year dynamics gives you this information. Okay, notice that velocity of the ramp did come out to be negative. That means that this drawing, although is correct, but it actually slides to the left. That's fine. Now, if one does a little bit more digging into Newton's second law, you can also find the time that it takes for the block to slides or descends by the amount h. I'm going to be using this thing for specifying the time duration of my uh, kinematic scenario in 3D experience. Okay. Now, so the first approach is going to be creating two prismatic joints, the one block on the ramp, the other one ramp on the ground, and then I'm going to run it. Here's the total duration, 0.87, which really 0.88, yeah. And I'm going to use symplectic Euler, and then what I'm going to do is I'm going to say, okay, let me take those prismatic joints away and instead just pretend that there's contact between the surfaces and there's no prismatic joint. I'm going to run it again, and we'll see how it goes. I notice that when you do that, you have to define contact. You're going to define contact between the ramp and the block, and the contact between the block, the ramp and the ground. Okay, so we need two definitions here, and I'm going to run. Okay, so let's go ahead and do the problem. I just want to check something here. Yeah. Okay. All right, let's go ahead and my dimensions, I'm pretty sure are already set on SI. We'll find out. So the first thing we're going to do is to make how about making uh, the ramp, okay? So insert 3D part. Just give it a minute. Okay, let me change this thing to uh, the ramp, okay? So properties, call it the ramp and ramp. I'm not sure what I called it here. I'll try to use the same name. Okay, so sliding block, moving ramp. So I'm going to call that thing moving ramp instead. Moving ramp. And same thing here, moving ramp. Yeah, let's go make it. So double click on 3D part. That's going to put us in the part design. Okay. So on a convenient plane, on that vertical plane, I will sketch a rectangle, a triangle, which has an angle 30 degrees. So let me see now, using profile, like this, go like that. That's going to be a ramp. Let's do some dimensions here. This length, this height is actually how, uh, one, 1 meter. All right. Now notice that what I did is the one that I'm using is actually uh, this height. Okay, this height is 1. So that thing is going to be 0.95 because this angle is 30 degrees. So this h is 0.95, but the one that I'm using is actually the left edge of that triangle. Okay, let's move it here. Let's do the angle between this and that. It's going to be 30 degrees. And it looks like my units are in millimeters. So let me go change these things, preferences. Where'd it go? Okay, I'm going to change that thing to meters. Everything else should be okay. All right, good. So this is 1 meter, as you can see. All right, so exit. And we pad it by, I'll make these things 10 millimeters. Let me see now. 10 or 20. Okay, so just so that we can see it. Okay, just so that we can see it better. Let me make this thing 100 millimeters. See how it looks like. 100 millimeter. Yeah, that's a lot better. Good. So this I'm going to make 100 millimeters. Yeah, that looks like that. Very good. Now this is pretty much done. So I'm going to go and insert my block. So insert 3D part. I'm going to rename this thing to be sliding block. Sliding block. Sliding block. All right, let's go make it. So double click on this vertical plane. I will sketch a square 100 millimeter by 100 millimeters. Okay, so let me see now. This is going to be 100 mm. 100 mm. Okay, good. And this is also 100 mm. I think that's probably what I want. And pad it by, what do I do, 100 mm? Yeah. Yeah. Okay, so there's the block. Okay, so then I'm going to do the ground, stationary ground. I think I called it stationary ground, if I'm not mistaken. Ground, okay, I'll call it ground, fine. Why don't I change the color of these things? This one I'm going to make yellow. Properties. Well, this is a moving ramp. I'm going to change this thing to yellow. Okay, I'm going to change this thing, properties, change it to orange. Right there. And then we're going to insert the third piece. Insert 3D part, and we'll call it ground. Okay, so let me change this thing, properties, change this thing to ground and ground. Yeah. All right, let's go make it. Double click on 3D shape. On a convenient plane, on that vertical plane, I will sketch something that is just a rectangle, and it's going to be the ground. So something like that. That's fine. And let me exit and pad this thing by 100 millimeter. All right, good. Go all the way to the top, all the way to the top, and we're going to apply some assembly constraints here. So engineering connections. Let me do the following, by the way. Let me snap these things to place first of all. Manipulate, snap. I want this face to be snapped to that plane. Okay, very good. And then another one, snap. These are not constrained. These are just snapping to the right location. That point to this point. Okay. And for example, this point to that edge. Snap it. Maybe let me try this edge and that edge. Oh, cancel. Control Z. Try it again. Snap. Select this edge to that edge so that the other guy moves. Yeah, very good. And it looks like this moved a little bit. That point, for example, to this edge. Okay, very good. Yeah, I'm not 100% sure whether actually uh, this thickness is 10, maybe it is 100 millimeter, maybe it is, maybe it's not. I'm not sure, but that's really not important. Okay, all right. So now we're going to apply our prismatic joints. So first of all, let's fix the ground. Engineering correction, fix the ground. The whole thing. Yeah, good. Okay, let's go. Let's go ahead and make our first prismatic joint, which is between the ramp and the block. So click on prismatic. The last this template number 7 right here. And notice that we have to select the edge and the edge, plane and the plane. And for this last one, actually, I'm not going to do it because we don't need it. We're not controlling the uh, prismatic joint. So I'm going to just going to delete and then say okay. And then okay, go. Now we do another one between the block and the ramp. So another prismatic joint. Once again, this template here, which is the edge and this edge, and this side plane and that side plane. And I'm not going to be controlling that distance, so I'm going to delete and say OK. Good. So we have two prismatic joints. Let me update these things. We have two prismatic joints, ramp and the block, ramp and the ground. Okay, we're pretty much done here. So now we're going to go to the mechanical systems design. This is where we assign masses and things like that. All right. You scroll all the way to the right at the very bottom. Scroll all the way to the right. Weight definition. In a minute. Notice that nothing has been defined. That's why everything is red. Let's start with the uh, the moving ramp. You click on it. So what I'm going to do is I'm going to make it out of steel, but then I'm going to come back and change the mass of it so that it agrees with what we have here. According to the drawing here, the mass of the ramp is 100 kilogram and the mass of the block is 10. So what we're going to do is right there, we're going to say declare weight. Click on it. Right now everything is 0. So if you click on this box, it's going to assign properties of steel. Okay, but I don't want that. I'm going to change that to 100 kilograms, and that takes care of the ramp. Okay, 100 kilograms, and close that. Now we're going to do the block, sliding block. You select on it, you click on it, and then declare weight. Again, check this box here to put properties of steel on it, but then we're going to change that thing to 10 kilogram as desired. Now, as far as the ground goes, the ground is going to be stationary. We don't have to put any meaningful value on it, but I think otherwise you're going to get some kind of warning or error message. You click on the ground. Once again, declare the mass, check this box. Whatever that thing is, we don't have to change it because at the end of the day, this is going to be stationary. So this is the mass of the ground. All right. Everything is blue, as you can see. Click, check that, get rid of it. Now, by the way, I want to get rid of all these planes here. So Control F, type plane here, find them and select them, and then I'm going to hide them all. Otherwise, you have to leave it there. It's going to be cluttering the screen, or hide them one by one. There's 9 of them, I think. Yeah. Okay. Once it finds and selects it, then we're going to hide them. All right. Put the cursor on it, right click and hide. It's a faster way of doing it. Okay, so we did assign weight. Now we're going to create our mechanism. Here's the mechanism representation. You can see that right there. Created. And then if you want to see what you've got, you click on the mechanism manager. You've got a fixed part 2 prismatic joint. Notice that the degree of freedom is 2 because I did not use any command to actually, control these things. That's why it says degree of freedom is 2. That's fine, no problem. Good. We are pretty much done here. There's nothing else to do. So now we're going to go to mechanical systems experience. It says create a mechanism. No, we have already done that. No problem. All right. Okay. Very good. Now let us create 2 sensors. Create one sensor on the block and another one on the ramp. So here is where you create a position, speed, acceleration sensor. The first one I'm going to call it block, and I'm going to select this corner point. So okay, and then another one I'm going to call this thing the ramp, in case you want to plot stuff. And for the ramp, you can select any one of these corner points if you want, or even the top one. But just to make sure that I don't inadvertently select the block corner point, so we just selected that corner point. Good, good. Now we're going to apply gravity, very important, gravity excitation. You click on it, and minus 9.81, very good. And now we're going to do a dynamic scenario right there. See that dynamic scenario? We already did the gravity, so send it to the right. Probe, we did 2 of them, send them to the right one. For parameters, and for this, I'm going to be using symplectic Euler and total duration 0.87 or 0.88, doesn't matter. So I'll use 0.87, and for the integrated type, I will use symplectic Euler. Don't change any of these. You may have to come back and make the time step a little bit smaller, but let's say okay, and see what happens. So put the cursor there on this branch, right click, and run it from here, or you can scroll all the way to the right here and run it from there. Either way, I'll do it like that. Okay, wait for a second. The block will slide down. Okay, good. That's exactly what happened. The block slides down and this ramp goes to the left, right? Okay, let's look at some results. If we go and look at the view scenario results, deselect everything. There's 2 sensors here. One of them is for the block. You can see that right here. And I want the magnitude of the velocity, which is right here. And you scroll down, you're going to come to the ramp. And again, you find the magnitude of the velocity. It looks like that. And you say plot tab. It shows you the graph of the velocity of the block and the velocity of the ramp. Now, if you want numbers, you click on the table tab. And notice that initially is 0, 0, both of them. And at the end of that time, 4.271, 0.361. Let me show you what hand calculation predicted. Okay. The hand calculation gave you these 2 values, 4.16, okay, and minus 0.36. So 4.16, 3.61. So we go back here. They're not that far off. 4.27 versus 4.16, etc., and 0.361 versus 0.361. That's very good. Now, let me do something else. Let's go ahead and instead of making prismatic joints, what we're going to do is we're going to do create contact between them. Okay, so let's go there. Let's go to our scenario. Okay, we have to create these joints. Now, these joints we should be able to do it in the you can create it in a mechanism representation, or let's go to the assembly and do it there. Actually, let me go here, mechanism representation. That's where we go. I went to mechanism representation, double click on this thing. This is where we can create our contact. So you click on the contact connection. Let's first do the one between the block and the ramp. So here, plus, select the block. And on this side, plus, select the ramp. Okay, so this first one is going to be between the block and the ramp. And because this is a surface contact that we've got, we're going to be using surfacic contact model, there are two tabs here. See that? There are two tabs. Once I select these two, there are two tabs. We select the surface contact. And for the coefficient of friction here, I put down point right here, 0.0000. I can't put 0 because when you put 0, it comes back and says 0 is not acceptable number. Okay, so I put a very small number there. In fact, so what I'm doing here is basically that piece. 3 zeros and a 1. It really doesn't matter. You can put 4 zeros and a 1 or 3 zeros and a 1. So that's the first one. Okay, so there's my first contact. Where are these things? Right there. This first one. This first. Oh, I think I forgot to do it. Let me try it again. Contact connection. Oh, cancel that for a second. Cancel that for a second. Now, notice that contact did not appear in this list, and there is a reason for that. It is actually over here, but not in the list there, and there is a reason for that. Because if you click on the mechanism manager, you see that this contact that I just created is not checked. If I check this, it's going to appear in that list, okay? But let me do that at the end. Cancel. Let's go do another contact. So group 1, select the ramp, okay. Group 2, select the ground, say okay. Again, surfacic contact, same coefficient of friction, pretty much 0. I can't put 0 there, it's going to complain, okay. And then we say okay. Now if you click on mechanism manager, right there, see that mechanism manager? I want these two to be included, but the prismatics to be removed. And then we say okay. All right. And let's run it and see what happens. Good. Let's plot our velocities. Deselect everything. For the block, let's select the linear velocity magnitude. And for the ramp, also the same thing. This is the graph, and this is a table of number. Very close to 0.36 and very close to 4.1, whatever we have. So, and by the way, you might wonder what happens if I use a different solver. For example, what happens if I use a, where is this? This was symplectic. What if I use the ASSL? Well, let's go ahead and see actually what it was. So double click on this scenario. The solver is symplectic. Let's make it DASSL. Let me say OK and run it. Oh, look, it's going sideways. See that? Go back. Deselect. Check it out. Linear velocity. This is for the block. Linear velocity. This is for the is a linear right there. Plot. And look at the numbers. Didn't change that much. However, you can see that this was going sideways. Okay. As a matter of fact, let me go ahead and double click on this. Yeah. So let me change this thing time step to 0, 1. See how it'll take longer, but it's a good idea to look at it. It'll take longer, but I want to see this thing whether it slides more or not. If I zoom in, you can see what's going on. See that? Now you won't have things like this happening when you have prismatic, and I mean, that may be what you want, but I showed you that you can do it with prismatic, you get excellent results, and you can do it with contact, you get excellent results. But you change the solver, there is some differences, of course. And this is what happened. All right, folks, good luck.